Welcome to EDU World Space.
From the statement of the problem, we know that we have two types of ions in a solution that creates a current. The first is that of the Ca2 plus ion, which has a charge of 2e, and the number of these ions is 3.24 times 10 to the 18, and they flow in a direction from B to A in half a minute. The next type is that of the Cl minus, which has a charge minus E, and the number of these ions is 5.11 times 10 to the 18, and they flow from A to B in half a minute. And E is the elementary charge given 1.6 times 10 to the minus 19 coulombs. And we're asked to find the current in the solution and the direction in which it flows, either from A to B or B to A. So in the next page, we'll solve this. And then what we'll do this is to first determine the total charge that's carried by each of the ions. So the total charge, Q, Ca2 plus, will be little q, Ca2 plus, times the number of these ions. So the charge it carries and the number of them. That will give the total charge. So this we know is 2e times 3.24 times 10 to the 18, which is 2 times 1.6 times 10 to the minus 19 coulombs times 3.24 times 10 to the 18. Okay, and I won't compute this number at the moment. I'll just leave it as is. And then for the Cl minus ions, well, again, we have Q Cl minus times the number of the Cl minus ions, which is minus E, and then the number of them, which is 5.11 times 10 to the 18, which is minus 1.6 times 10 to the minus 19 coulombs times 5.11 times 10 to the 18. Okay, and now we're going to find the current that's associated with each one of these total charges. So the current is defined as charge over time. So let's find the current associated with the Ca2 plus. So that is equal to Q Ca2 plus over T, and we have the Q that's given up here. So we have 2 times 1.6 times 10 to the minus 19 coulombs times 3.24 times 10 to the 18 divided by half a minute, which I'll convert to seconds. So half a minute times 60. So that gives me in seconds. And when I calculate this number, I find that I have 0.0346 amperes, or 34.6 milliamperes. Okay, and this is going from B to A because that is the direction which we are told that the charge of Ca2 plus flows. Now, we have to be a little bit more careful when we calculate the current that's associated with the Cl minus, because the current defined in the direction of the positive flow, but these charges for Cl minus are negative. So when we have a negative charge flowing in one direction, it's as if we have a positive charge flowing in the opposite direction. So we have to pick up a minus sign to compensate for the definition. So we have minus QCl minus over T. And the QCl minus has a negative sign in it over here. So this minus sign times that minus sign gives me a positive sign. And my product now is just positive. So I have 1.6 times 10 to the minus 19 coulombs times 5.11 times 10 to the 18 divided by my half a minute converted to seconds. And this gives me 0.0273 amperes, which is 27.3 milliamperes. So the total current then, let's do it on the next page. So the total current is the current of the Ca2 plus the current of the Cl minus, which we found to be 34.6 milliamperes plus 27.3 milliamperes, and then that gives us 62 milliamperes, and that's flowing from B to A.